All right. This is chapter 3, question number 3. How much momentum does a 0.5 kilogram rock have when thrown at 25 meters per second? Since momentum is equal to the mass multiplied by the velocity, it's a simple matter of taking that mass and multiplying the two together. You get 12.5 kilogram meters per second. And for number 4, it asks about impulse. Impulse is equal to the change in momentum, which is equal to, since P is equal to mv, we could say that one of these two factors has to change, and it's usually velocity. So P is equal to m times the change in velocity, and since it wasn't moving, and now it is moving at 40 meters per second, the impulse is 4 Newton seconds. And the units could have been kilogram meters per second, but generally impulse is measured in a force multiplied by a time, so a Newton second. And let's just go with number 5 as well, since these are all similar types of question. A 2.5 kilogram cart moving at 0.64 meters per second collides with a stationary cart over here that is 1.8 kilos. The carts lock together, and so they have a combined velocity at the end. Basically, we have m1v1, that's for mass 1 and velocity 1. And the initial velocity of this one, m2 and v2, the velocity is 0. So we can essentially ignore the initial momentum of that first cart. But let's just put it in there so we remember to do that. In the end, they lock together. We show that by putting the two and multiplying by the same velocity. This is the combined velocity of the pair. So this one is 0. m1v1, 2.4 times 0.64 must then equal 2.4 plus 1.8 times v. Solving for v, we get 0.366 meters per second. Final answer.